Hi, we're going to talk about pointers in C. So as you're probably familiar with, pointers refer to a specific spot on RAM in C. So let's go ahead. We have our standard boilerplate here. We have our include stdio. We have our include stdlib, standard IO, and standard lib. Okay. How I got to this point, I'm in Linux, right? So basically I went to documents. I went to my desktop. I can just show it to you here. So I went to my desktop. I opened home. I opened documents. I created a pointers.c, okay? Then I double clicked on that, and that's how I got to my editor. So here's my editor. Notice it has colors on it, right? So the code is highlighted. I also went to documents. I right clicked and I clicked open terminal, okay? So let's go ahead and do that again. So in documents, I right click in this empty area. I go open terminal. Okay, so the idea here is that, and notice there's my username, at my computer name, and then where I'm at on the computer. So the colon is kind of the separator there. I'm in my home directory, that's the tilde, and I'm in the documents subfolder of the home directory for the user. CS on the computer, CS virtual machine. Okay, so once I'm done, once I'm to a point where I want to run the program, I'll go ahead and go into this terminal right here. All right. Now I know it's a little bit confusing because both of them are black screen. Okay, but you won't get confused if you're doing it yourself. So, okay, so we're in our program. Let's go ahead and we're going to type in. We're just going to declare a couple of variables here. So the first thing we're going to do is we're going to declare int x equals 10. And so that, as you know, is I'm saying it's a type int, right? And the variable's name is x, and I'm placing a value of 10 inside the variable x. Okay. All right. The next thing we're going to do is we're going to go ahead and we're going to declare a second variable. Okay. So now we're going to go ahead and declare this int, and then we say int. That's the type, right? And then it's a pointer. That's the little asterisk right there. It's the same symbol we use for multiplication, but in this case we're saying that it's a pointer. And the pointer's name is y. Okay? So when we declare a pointer, it has to have, we still have to say what type of data is going to be held at the address that the pointer is referencing. Okay. So let me just say that again. We have to say that there's an int because we're saying, hey, at the address that we're storing in the pointer y, that is an int. Integer, the data is of type int. Okay. The next thing that we're going to do is, so the thing that a pointer variable can store is an address. So let's just be clear with that. So we have a variable called x that's holding an int. Okay. We're then going to declare a pointer. Okay, that's y. Okay, notice that we're saying that it's a pointer that points to a place in memory that is storing an integer value. Okay, and then we have the second operator here. So y equals. This is how we get the memory address for x. So when we declared int x equals 10, that was stored to memory, and it was stored to a specific location on a piece of RAM, on a stick of RAM. Then when we say %x, or not percent, ampersand x, basically we're getting the address for that spot in memory that the integer 10 is being held at, and then we store that address in y. Okay, so is that relationship that you really have to be rock solid on that relationship between those three values. So 10 is the data that's being stored. Y is the variable, or sorry, x is the variable that's storing the value of 10. Y is a pointer, and we first do this, that doesn't hold anything. We're just saying it's going to point to an int value. and then we can get the memory address of x and store it in y. Okay, now obviously we couldn't just store the memory address of x in an int value. Okay, it has to be a pointer, right? Okay, so let's go ahead and print out some of these values. So let's go ahead and print, we're going to go ahead and print the value of x here. All right, so let's take a look at this statement here. Print f, and then we're going to, in parentheses here, we're going to get the value. Okay, so we, you know that our string that we're going to print is value, whoops, is value of x, colon, and then we have our code, right? We have our %d. That's going to get replaced by our value over here, right? And then we have a line break, \n. Okay, all of that's in a double quotes. All right, so x is going to be placed into this string right at the location of %d right there by the printf function, and that should print out to our console. So I'm going to go ahead and save this, and I'm going to go over to our terminal. So notice that I launched the terminal. See where it says Documents? If I go to the place where this is saved, notice that they match. Okay, so if I take a look at the top of my screen here, if you can see where it says pointers.c, and then in parentheses it says ~/documents, notice that that matches right here with this path, ~/documents. All right, so I've already typed this in. Notice I hit the up arrow to get back in my my set of things that I've typed into the terminal, and I typed in GCC. So my file name is pointers now. Okay, so let's take a look at what I'm typing in here. So I call GCC, right, GNU compiler collection, GCC, and then I have a space, and then I tell GCC, hey, this is the file I want to compile. It's pointers.c. So the next space right there that this next part is the file that I want to compile. Then I say, hey GCC, I'm going to send you, this is the output flag, -o. Write the output, the executable, to a file called pointers. And I hit enter. And now when we go into our documents folder, if I can open this back up, whoops, you'll notice that now we have pointers. So that's the file we just made. So let's go ahead and delete that, and let's do it again. So notice that I'm going to delete it. Delete the other one. Okay, so now I have two .c files. One is pointers.c that we're working on now. Okay, so I hit up to run the command again, hit enter, and notice that the compiler created this new file right there. All right, the next thing we're going to do is execute the program. So we're going to go ahead, we're going to click, I'm just clicking up. Basically, we want to get to period / and then the name of the file that we just created. So that's our executable pointers. And I'm going to go ahead and hit enter. Okay, so this says that the value of x, value of x is 10. That's just what we would have expected here, right? Okay, we just stored the value of x as 10. All right, so let's go ahead and take a look at what the value of %x is here. Okay, so we created this y, right? Let's see what the let's see what the value of not %x, %x. Okay, so to do that, we have essentially the same statement here. We have our printf statement. I just copied it, right? So we're going to go ahead and say the value of %x is equal to %p, so that's the code for pointer, and then line break, right? Okay, and the pointer that we're going to send is that %x. Okay, I'm going to go ahead and save that, and let's go ahead and compile it again. I'm going to hit up arrow, launch it again. Okay, so here is our memory address. All right, so that's just what we would have thought, right? So we have our variable x, it's an int, right? Storing the value of 10. We say, hey, get the memory address of x by doing %x, and this is our memory address. Okay, now I stored that memory address. Remember when we said y equals %x, and notice how it wasn't *y. Okay, so it wasn't *y or *y. right? Okay. So let's go ahead and say the value of y, okay? And let's go ahead and get the value of y. Now in theory that should be the same, right? It should be the %x. Okay. So we say that I'm referencing the, so y is like a reference to that memory location, right? So in a minute we'll be dereferencing. So I want to make clear that this is a reference to a memory location, the $x and the y. Okay. So we saved it. We're going to go ahead and recompile. All right, so here we have value of x is 10, value of $x is a memory location, value of y is the same memory location. Okay, but now let's say that we want to get the value that's being stored at the pointer. All right, so now we have to dereference the pointer. All right, so now we can say, okay, now I want to go get the value at the pointer. And for that, we're going to use this asterisk y. And remember that when we get it back, it's going to be an integer value. So we have to change the flag to decimal, right? %d. Decimal works. We could use %int. Okay. And we're going to dereference y by using this asterisk again. So notice that we use the asterisk a couple times, right? We use the asterisk when we declare a pointer. We don't use the asterisk when we assign a value to a pointer, but we do use the asterisk when we go and get the value at the pointer, when we dereference the pointer. So I'm going to save that, recompile, re-execute. Okay, so it's just as we would have expected. So we have x is 10, $x is a memory location, y is a memory location, and the value of d for reference y is 10. Okay, so now you might be saying, well, that's all well and good, but how can this possibly be used? What is the value of this? All right. So let's say that we want to create a function, okay, and we want to pass that function some value. Does that make sense? Let's say that we want to create a function called int change value. Okay, because I'm very creative. All right, we want to call it int change value. All right, and we want to just change the value of x. That's all we want to do. Okay, we want to change the value of x. In C, we're going to need to go ahead and use pointers for this. Okay, so the very first thing you should be noticing right now is that if I were to run this, is this going to work? Well, let's just see. Okay. Let's say that I'm going to return x. Let's say for now I'm going to return 0. Okay. And let's go ahead and call this function from inside of main. Okay, so we have this function, right? It's its most basic level here. We have this function. Okay. And it's going to return a 0. Okay, so let's go ahead and just see if that part works. All right, so we have a function. It's of int type. It returns 0. And we're calling that function. Let's go ahead and see what happens here. All right, so in this case, I'm going to recompile. Whoops. Already a problem. Whoops, I forgot my my semicolon there. Okay. So in this case, I get this problem, right? So I get warning, implicit declaration of function, change value. Okay, that's because the first time that C is encountering that function is right here on line 15. Okay, it doesn't know what to do with it. All right, so it implicitly declares a function, but then it's redeclared down here, and that's a problem. So what do we do in this case? Well, what we do is we actually declare the function up here. Okay, so we're going to go ahead and declare the function int change value. Okay, I'm going to save that. And that compiles just fine. Okay, now, so we want to go ahead, and our goal here is to change the value of x. Okay, or to do something to the value of x. Let's say we're going to change the value of x in some way. So what we're going to go ahead and do is we're going to go ahead and we're going to input. We're going to take in the memory address. Okay, so the pointer to the x value. Okay, so in this case, we're going to call that, we're going to have this pointer z. Okay, and we know that we're going to use a pointer in here, so we're going to go ahead and in our initial declaration, in our prototype of the function, we're going to go ahead and add in that in pointer as well. So now what we're going to be doing is we're going to be passing in this memory value, okay, in the form of this pointer z. All right, now all this needs to do is be of the right type, right? It has to be a memory address, and that memory address has to hold an integer. All right, so what we're going to send over is we're going to go ahead and send over y. Okay. Let's go ahead and save it. And at that point, what we're going to do, so then inside of change value, we're going to go ahead and we're going to say that, remember we have to dereference z, so we're going to go ahead and asterisk z equals 15. Okay? So let's think about a little bit about what we're doing here. So remember, we're storing the memory address for x. Remember that ampersand x in the y pointer. Okay, remember we declared this y variable as a pointer. So we store the memory value for y for x in y. Then we're sending over that memory value. Remember what the memory value was? It was like some hexadecimal number, right? Okay. So we send over that memory address value, and we take it into int change value, okay, and we take it in as a pointer. Then we go ahead and we dereference the pointer. We say, okay, wherever that memory location is, now we're going to make it a 15. All right? Okay, now in this case, we don't really need to return anything from this, from change value. But let's wait for a second to do that. Okay, so we're going to go ahead and compile. Oops, I always forget the semicolon. Okay, we're going to go ahead and execute. Okay, so that went ahead and executed. Now, we got a couple issues here, right? Because we didn't add another print statement, so we don't really know what the ending value was. So let's go ahead and print the value of x here, right? Okay, so we're going to call change value, and then we're going to get the value of x again. Also, we're going to go ahead and change the type of the change value function. So we're just going to go ahead and call it void because it doesn't. We don't need it to return anything, right? Because we're not using the return value. So in this case, we're just going to make that void. Okay. So let's go ahead. Let's just go ahead and print all of them again, and let's see what changed. Okay. Okay, and we'll even put in print values for z down here. Okay, so we're going to go ahead, we're going to get z. I really like print values because they're going to be able to show us what's going on. So we're going to add quite a few print values here. So we're going to go ahead and do print the value of z before and after the change, right? Okay. And we're we're going to even print value changed here. Just a puts. Okay, so we went ahead and added quite a bit here, right? So what are we going to do? Okay, the program's going to print out all the original values that we looked at. So we have x, we have the memory address of x, we have the pointer y, which is a memory address, the dereference value of y, which should be equivalent to x. Then we call change value. Okay, change value, we send over y, the pointer y. We take it into the function change value as a pointer z. Okay, but the memory addresses should be the same, right? Or they, in theory, they should be the same. Then we're going to print the value of z. Oh, sorry, this should say address, shouldn't it? Oh my gosh, I went through the whole thing. So wherever we have a %p here, it should be address, not a value. Okay. Okay. So we call change value. We bring in z as the pointer. We want to see the address of z, see if that changes. We see the value of z. Then we dereference z. We change its value, and then we're going to print out value changed, and we're going to print the address of z, and we're going to print the value of z after the change. And then the next thing will happen, so we called that function, right? The next thing that will go off is the 18, 19, 20, and 21. So we're going to take a look at the value of x, the address of x, the address of y, and the value of the dereferenced value at y. All right, so we're going to go ahead and save that, and this will be our final thing here. Okay, so we go ahead and compile and execute, and let's take a look at what happened. Okay, so just as we would expect, just as we would expect right here. So notice that each time I execute, the memory value is different. But on this execution, notice that the addresses were consistent, right? So as I passed it over to the z value in the other function, when I passed it and then continued on, the address was always the same. So we were always dealing with the same area of memory. The value of x is 10, the dereference value of y is 10, the dereference value of z is 10. We change the value right here. The address stays the same, right? Then the dereference value of z is 15, as is x, and as is y, because they all reference the same thing, right? So the value of x, the dereference value of y, and the dereference value of z all are identical. They're all referring to the same exact memory location. All right, so rather than making copies of the data and passing the data around, we're using pointers to allow the program to change the data directly in the memory rather than copies of the data. All right, good luck with pointers.